My name is XIANJUN. It's really my honor to have this opportunity for an interview. Thank you for the organizations of the Second International Research Awards on Computer-Aided Design in Mechanical Engineering. Thanks so much for the Science Father. I received the doctorate degree in 2017 in Aerospace Manufacturing Engineering from Harbin Institute of Technology in China. Today, my report topic is investigation of laser-assisted machine aluminum matrix components reinforced with silicon carbide particles by 45% volume fraction, mainly include 5 parts. The one is introduction, the second is thermal model and temperature field prediction. The third is chip formation mechanism and the constitutive model. The fourth is the mechanism and improvement in laser-assisted machine metal matrix components. The last is the prospect. Particle reinforced metal matrix components have been used in the aerospace industry. Optical instruments more and more popular due to their superior properties, such as excellent strength to weight ratio, low thermal conductivity. However, it is very difficult to machine due to the quickly to wear. The shape to wear is attributed to the hard particles strengthening the two flank faces. Nowadays, only polycrystalline diamond tools provide an acceptable tool life. However, due to the extremely high cost of polycrystalline diamond tools, common tools like cemented carbides are also used in laser-assisted machining of these materials. Next, I introduced the laser-assisted machine technology. Laser-assisted machine is integrated cutting process. A laser beam is used to heat the workpiece in front of the cutting. The elevated temperature at the shear deformation zone makes the materials deform there. The figure is laser-assisted turning schematic diagram. Figure B is laser-assisted milling schematic diagram. The elevated temperature at the shear deformation zone makes the material deform easier. Its benefits include a reduction in the cutting forces, longer to life, better surface integrity. A three-dimensional heat transfer model was developed for laser-assisted machine of metal matrix components using finite element method to predict the temperature field of cutting zone. The model was based on temperature-dependent thermophysical properties and the heat conductivity equation. The heat conductivity equation is described by the equation 1. To verify the thermal model, the infrared camera was used to measure the maximum temperature. The prediction of the laser and the measured temperature are shown in Figure 3a. The temperature history of the three fixed points, point 1, point 2, and point 3 along the center line was recorded. Next, introduce the chip formation mechanism and the constitutive model. The most efficient ways of studying the machine characters of any material is to study its chip formation details. So a quick stop device was used to produce a full chip in the conventional and the laser-assisted machine types respectively. The schematic of the laser-assisted machine setup is shown in Figure A and B. The ICM image of the chip routes from conventional and laser-assisted machine tests are shown in Figure 1. the magnifying SEM imaging of the chip root from conventional machine so that many broken particles are mainly observed ahead of the tools because of the bigger shear stress and normal force applied by the two rig face. Based on the chip root microstructure, a chip formation physical model was developed, as can be seen in figure. There is first void formation around the particles due to the multiple stress caused by the two rig face. Once the materials were sheared further, the coalescence of the voids caused the cracking to grow and propagate along the shear plane. Figure 9 indicated the ICN micrograph of the free surface of the chips. We can see from figure A and figure B the shear deformation band is more wider in conventional machine and laser assisted machine due to the more heat is generated in shear zone in conventional machine. A bigger tooth span and height variation are observed from the chip root in laser assisted machine than in conventional machine. Next, introduce the constitutive model based on the deformation mechanism in laser assisted machine. A constitutive model describing the relationship of the flow stress, strain rate, and temperature was developed. Laser assisted machine experiments were conducted to determine the coefficients N, M, P, and Q. Next, introduce the mechanism regarding performance improvements in laser assisted machine or mathematical complex. The effective temperature on the cutting forces are shown in figure A. It can be seen from the cutting forces reduce with an increase in temperature in all three directions. Figure B indicated that the tangential cutting force was reduced by 20%, 30%, 30 and 9% when the temperature increased from room temperature to 2020, 3020, and 4020 respectively. Figure A and B indicated the distribution of precipitation strength in phase in conventional machine and laser assisted machine respectively. Figure A shows that more precipitated strengthening phases in aluminum matrix rooted in the laser assisted machine. This is another important factor which reduces the cutting forces in laser assisted machine. The next part is the prospect of laser assisted machine. By combining laser assisted machine with the whole precise simulation technology, using obtuse secondary development technology based on the residue stress redistribution calculation model, the finite element simulation model was modified to analyze and identify the maximum machine deformation. Laser assisted machine combined with anti-fatigue manufacturing. Anti-fatigue manufacturing is an important method to improve the life and reliability of the thin walled components. The surface integrity of the produced products is tested and evaluated. According to the evolution results, the precise data is analyzed and the precise parameters are optimized. That's all. Thanks for your attention.